Okay, hi everyone. Thanks for joining me after lunch. We're almost getting to the end of the Big Data Vilnius. There's a couple of talks left. So today I'm going to be talking about design philosophy of Apache Airflow ETL pipelines. As you will notice that there's actually quite some differences how you would approach the ETL correctly and with a lot more ability to reproduce the data and get things flowing properly. So to start with, I'm going to talk to you about the things that I've seen. I've been working in some companies where we were creating views over some database tables. Some of them, they had 7 joins, and it was duplicated 6 times. That would yield a 1200 line view just to calculate 3 types of very similar measures that were all duplicated because of a single nullable column, right? So, and all of that was pushed into the same table. So there was a really complex piece of code to maintain, actually completely unmaintainable. And the way how we got there was because of the volume of the data and the way how the ETL pipeline was approached. In the same data warehouse, there were 4 different implementations of margin. One of them was a very basic margin. Another one was a margin with all the cost involved and calculated in it. Yet another one was only calculated for marketing and for Google AdWords purposes. And there was another margin that nobody was using and that we deprecated right away when I got started. In this data warehouse, there were over 1 billion records replicated on a daily basis out of 250 tables. That was a transactional data store. And all the measures over the past 4 years were recalculated almost on a daily basis. They were recalculated completely on a Sunday. And on every day, they would be recalculated for the past 30 days or only for the past day, depending on what this metric was used for. And in the end, they had 3 different implementations of sold product quantity. Sold product quantity is a metric of how many products you're actually selling. And when you have all these different implementations, then when there is a user who needs to look at some of the data, if they're looking at a marketing cube, if they're looking at a sales cube, or if they're looking at other data, maybe in the tables themselves, they don't know exactly how these figures are built, what the difference are between them, and if some of those sold product quantities, for example, are already offset against the returns that are made. So that was getting very complicated. So I think it's time to do things differently, try to get things more organized. And what this talk is about is how you can approach the ETL pipeline, data pipeline, from a functional perspective with the objective to get a lot of cohesion and a lot of oversight into the whole data pipeline process. So first of the things that we're going to talk about is that you need to process data in partitions. Instead of working on a whole table that you bring in and then process over that into the future, at some point as your company is growing and your volume is increasing, when you process data over the whole table, that doesn't work anymore. A very interesting thing to think about nowadays, especially in big data, is that you need to think about data addressed to data addressed with simple operations between them, because it makes them functional and testable. There's going to be, you need to deal with changing logic over time because your business changes. In the end, at some point, when there was a particular kind of logic that was applicable at the time, maybe even like tax rules, at some point you want to be able to choose which rule you're going to apply in time. And if you want to make it rerunnable, you need to put that somewhere in your workflow. I've mentioned this before as well yesterday in the talk. There's the use of a persistent staging area. It hasn't been very popular because of the duplication of data, but I think that is changing very rapidly. And we're going to be talking specifically about functional programming, what functional really means and how you can apply that to data. The parameterized workflows are important for us because when you parameterize your workflows, you'll be able to use them in a lot of different situations, and it makes it dependent on the context in which a job is run. I'm going to get into that as well. And that it is important to implement data checks as part of your workflow. So not just running a workflow and then trusting that it works without seeing the data, but you're going to confirm as part of your workflow that the data is being run through that properly, so that you have particular checks in place that fail if the data is not up to date. And I'm going to look at alerting and SLAs also as part of a functional data pipeline. So the first thing is about the partitioning, which I also mentioned yesterday. Partitioning data basically means that you're going to define intervals for your ETL pipelines, and those intervals are usually about 1 day. When you build those partitions, you want those to become immutable, because when they are immutable, you can reproduce a particular state of data that is historic and then reapply it again, and you can look into the data to see what the problems are. Because, as I was mentioning, when you replicate the database that is transactional on a daily basis, there are changes that are happening in that transactional database that when you rerun a particular data pipeline, the data is going to be slightly different. And when you rerun the data pipeline, for example, between a production and UAT environment, you might be able to just use the same PSA that you have created from a production environment to switch that both to a production environment and a UAT environment, so that you use exactly the same data and you can make things completely comparable between them. The way how you would use those partitions is that you always apply insert override rules. So you would never use merge, like immutable operations anymore, like update or delete. You would have a clean partition, completely overwrite it, and that is going to be the data, so that you have a pure or like a functional function in order to do that. We'll get into that later. And the partitions, they always align with the ETL schedule that you have for that particular workflow. So that can be a day, it can be for hours, but there might be some workflows that you have in place that you want there for 15 minutes because you want to show to the business on a Black Friday how many sales are being made on a 15-minute basis, so that people keep track of what is being sold and what the effectivity is of particular communications. So here's an example of how you would partition the data. We always start with the raw data that is coming in from a PSA. You would put that into a staging table at some point. And all these partitions, they are partitioned by date. So you can see all those date partitions in there. And you can see how they are moving forward and then also being combined together. So when you have at the very last operation the aggregation of sales, that will be some function that will read from two partitions as a source and apply that into the very end and create its own partition there. When you use this methodology, it means that all of these partitions and all of these tasks that operate on them can be completely parallelized. If you don't do this and you read from the whole table in raw, for example, or in sales, it means that you have a loop where you need to do sequential processing, and that can be quite complicated and consume a lot of resources. Here things become manageable, and it will also be rerunnable consistently between days, so that you don't have to reprocess a lot of data. So I was talking about the dependencies that you would sometimes have. What you need to avoid is that you have in these data pipelines these self-dependencies on their own data, because when you introduce them, you're going to have to rerun those partitions in a sequential nature, and it's going to delay your data pipelining strategies because it isn't parallelizable anymore. So it's important to both avoid these self-dependencies, but you should also try to read from a limited number of source partitions in the first place, so that these pipelines run very quickly and very smooth. So I was talking about the changing logic over time. I've seen cases where a business rule is changing, or there is a change in a source system that implies some kind of change, how you would process that later. When that happens, often what people do is they go into the source code and change it and then statically apply that going forward, right? But your historical data is still based on the old way of doing things. So if you're using those partitioned methods to process your data, what you can introduce in your workflow is a branch method called select processing method. And the only thing that that does is look at the current execution date to determine which particular function to execute. So that if the tax rules change, or if other business rules are changing, you're able to deal with that. And at the same time, you're going to be able to go all the way back in history to reprocess your entire analytics data set. So that's a very interesting way of doing it. So the persistent staging area, there's a benefit to having a persistent staging area. If you're thinking about sources where you're taking data from, some of them can be HTTP interfaces or FTP interfaces. And when you deal with those, you always have a lot of latency, and you make yourself dependent on sources of data that are not under your control because they're controlled by other companies, for example. And when it happens, you always want to have something in the middle to have as a buffer against that. Because I've seen, for example, an HTTP interface that we were using for delivery data, and because of the volumes that were increasing in the number of deliveries that we were making, the company couldn't keep up with the data volume and asked us to reduce the volume of data that we were querying. So we had to reduce from a whole day to half a day to 5 minutes of data at each time, which results in a lot more calls and windows of data that you get in. So what we did was actually query the data and put it into the PSA or some other data lake, if you like. And then when that flow is done, you would just pick it up from the data lake instead. So you don't have the complexity of dealing with the other system, which might not even be live at the time, or might be very slow because of consistent queries on a daily basis that are going on from the actual live system. So the persistent staging area isn't very popular historically, because what people think of it is as another way where data gets duplicated. So in typical database and warehouse systems, they wouldn't really use it because it would just significantly increase the volume requirements. But nowadays storage is a lot cheaper and it is also distributed, so it is a lot easier to just implement it. And for example, in a cloud bucket, you can just create your own staging area and then all the data remains there. What it does is basically maintain the full partitioned history and ideally with a schema, so that if you have schema changes in those particular data sets that you're saving, you're able to detect it and match it against a processor that you need to process it with. And some people that I talked to, they were saying that it is a bad method because it's not a backup of your database, but these cloud buckets, they have 9 nines of durability, which is probably a lot more than a backup can guarantee you. And if that is the final way of generating your regenerating your entire data warehouse, that is probably not a very bad method to start with. The only issue that might be an issue is that there is only 99.99% of availability, so some of those calls that you're making to get the data might fail. So I talked about reproducibility, and there's a very important thing that it's basically a very important quality that your ETL pipeline should have. It's foundational to the scientific method, and you want to do this from the legal perspective in certain cases, to be able to produce exactly the same data as you had in the data warehouse at some time ago, if you need to reproduce those particular perspectives. There's the need for bug solving. So if you have a bug in a data warehouse, you want to be sure that when you grab that partition that you can actually figure out what the bug is in there. Then there's also the design issues that you want to fix. If you make particular design choices very early in your system, there's always going to be something that is not entirely right or that you want to change. And when you use the functional strategy, it will allow you to upgrade your designs in the future to do something completely different, especially when you have a PSA. So you can actually migrate to a totally different data warehouse design than you're now working with. And of your sanity, I think there's a number of things that if things are not reproducible, you're going to chase after data, and from one day to another, things are completely different. And I've seen cases in particular systems that were so incredibly complex that they couldn't make that consistently reproducible anymore. So they were chasing after those bugs in the SQL. So if you approach this functionally, then you get the reproducibility that you want. So we're going to talk about functional ETL, and there are 4 keywords that are important there. One of them is the pure functions. I will explain what they are. And then there are 3 other concepts that are really important to also maintain to make the whole data pipeline functional. One of them is the pure functions. Pure functions are basically from functional programming, and they're defined as limited to their own scope, and the output depends only on their input. So if you have a function with a particular input parameter x, then it will always produce the output only depending on that input itself. There are no side effects in the functions, so it doesn't open files or it doesn't do other things that might have some side effects in other systems. And that makes them very easy to unit test because you don't have to deal with global variables or other state that you have to maintain. You just call a function and that is it. And that also implies that inside the function there are no mutations going on. And ideally, you would do this with a limited number of source partitions in order to also keep your testability to a reasonable level, and also to keep the scope of the thing that you're testing and running to something reasonable. So as an example of pure functions, what they are, at the left you can see a correct pure function implementation. If you call this, you will always get that result, and it is only dependent on the input variable. In the middle, it is not a pure function because I've created a global variable, and a global variable has a state, and that state is manipulated inside the function itself. And that makes it not a pure function, but it doesn't necessarily mean that it cannot be made into a deterministic function. We'll get into those keywords later. And on the other one, you see a file being opened, and from that definition, there are some side effects being generated in the function, and that is also why they're not a pure functions, because there might be, some of those side effects going on. So getting into immutability. Immutability is probably a keyword that people already know from Java programming, where you have strings that are immutable. You assign it and then it is fixed. If you try to assign it again, it will just create a new variable under the covers. It will not point to the same slot as it was pointing before. And in data pipelines, it means that when you have immutable partitions, as soon as you process the data and write it somewhere, you no longer mutate it afterwards. You just leave it there as you have produced it. So there are the two keywords that are remaining are idempotency and determinism. Idempotency and determinism are they are sort of related in a way. It means that when you call a particular function, that there will not be changes in the output state when you call it multiple times. So, for example, if you call a function 5 times, it doesn't lead to 5 duplicates in your final data set, but you will only have 1 copy of your data set. And deterministic means that the function's output only depends on the input, not on hidden or global state. And that is related to using the insert override function, that you clear the area first, and then from the input that you're giving to that function, you're getting another output from it. And then that will always be the same output that you get, even if you call it 1,000 times. So those two together are the most important. Because we are dealing with state that we are generating in data, those functions that we're going to talk about are not necessarily pure functions, right? So that's also important. So the parametrized workflows. Here what you see is an operator in an Apache Airflow DAG, and there's a couple of things that are quite interesting to say about it. These are operations where the whole complexity of connecting to BigQuery and connected to Google Cloud are abstracted. So you get an SQL query that you want to execute. You're going to specify where you want the results to go, and then you have the right disposition, right truncate, and it will create a table if that is needed. The right truncate is actually the same implementation as insert override in Hive, so that is going to give us the ability to deal with this in a functional manner. There are other things in BigQuery that allow you to use write append, for example. And write append is thus not so good because you might end up with duplicates of your data. So what that looks like in the parameterized workflow is could be some of that SQL. You will see that the bold bits are basically inserted into the query itself, and naturally those are related to the date in a way, because we are dealing with partitions and we want to see from an analytical perspective use the date as a means to recreate new partitions that are going back from that date backwards to 7 days or 27 days, for example. So I was talking about the data checks that we need to do on a daily basis. If you think about Airflow as a platform, there are multiple things that actually need to be tested. Underneath, you have the hooks that connect to those systems, and those hooks are generally tested on your local development machine. And there are also the operators themselves that have some functionality in them, and those should also be unit tested. But then when you run those operators as part of a DAG, there are two separate concerns that are remaining. One of them is if the workflow that you have defined is actually correct and the SQL is correct. But the other thing is that some of the data that you're going to work with can be a little bit unpredictable. For example, it is possible that when you call an HTTP API that you are actually not returning any records. And then when you actually did expect some records, because you always have some records in that particular data that's being generated, it is very important to check that the data that you think that you're ingesting actually lands there. So what this data check does is that after the load data operation, it's going to first check if the number of records is correct, and then it starts to calculate the measures when it knows, okay, I have ingested some data, so probably this is the right amount. And from there, you can actually see that it will generate another check to see if the measures have some certain tolerance with the 7 days ago. So when you implement those checks consistently, it will allow you to trap problems that would occur in a typical analytics flow very early, so that you don't have users that are going to talk to you about how some of the results that they are expecting are slightly off, and then you have to look into the data why that happened, and this will allow you to very early trap that and notify you of those occurrences. So the final thing that we have for the functional pipelines are the alerts and the SLAs. And alerts and SLAs are, I think, a very important thing to look into, because this is also one of those management data pipeline management issues that you need to deal with. In Airflow, what you do is typically you create a default args structure, and this default args structure will allow you to specify the default arguments for all the operators that you're using. And here we specify that, for example, we want to be notified when a task fails, but we don't want to be notified when a task is going to be retried. And in the bottom, you see the SLA with a time delta of 5 hours. And what that means actually is that when this DAG run is started, the DAG is started, every task that doesn't meet, isn't finished 5 hours after the DAG was started, will be included in a single email that is sent out to the team listed in that email, so that they know that some of the SLAs is being violated. And that could be that there's a lock in your database or your warehouse, or there are some other issues occurring with a lot of latencies. Maybe the workers are congested and so on. So you can look into that. The execution timeout is there because there are sometimes really long locks that can really complicate things a lot, and it can completely congest your entire database if you're working with a smaller one. And what that does, it will terminate the entire DAG and also all those jobs that are running, so that you give some more freedom for other things that you still want to have continue. And at the bottom is just a DAG definition where you see the scheduling interval being set at midnight to run on a daily basis. So ETL with Airflow, this is what we have discussed. These are the important points for making it functional. You process the data in the partitions, you rest data between the tasks, you deal with the changing logic over time using the branch Python operator. There's a persistent staging area that you can use, and there are you can apply functional programming to your data pipelines by looking at how you're processing the data, and the data checks and the alerting. So one of the other things that came up was very interesting is I was talking about it yesterday a little bit. It's related to Kimball, and some of the things that where complexity is going to increase over time, but not exactly from the beginning, is when some of the design choices that you're making are not necessarily correct anymore. And then you have to deal with solving those design choices and reworking it to something else. So there's another thing about Kimball where it is subject to mutations. So you're actually mutating the data that you have already loaded going forward. And a lot of the concerns are covered in a single statement. So when you have your staging data and you have your data warehouse, all of the complexities of combining your different sources and aligning your grains are done in one single statement. And with type 1 SED, you lose your history, and maybe at some point you want that history back. So what was suggested by some people working at Airbnb and what they are using is that instead of choosing type 1, type 2, type 3 dimensions, since they are running this on big data, they simply snapshot all the dimensions on a daily basis. And the efforts or the benefits that it gives you is that when you look at the facts and you look at the DIMs, you want to put them together, you can do that on two different ways. You can look at the dimensions as they are currently defined as today, but you can also combine that with the way when the fact was generated. So what the dimensions look like at the time of the fact generation, the event that came in, like a sale, for example. So this is a very nice way of dealing with those problems, because you get a lot more flexibility in how you want to query the data and what kind of dimension you want to apply. And it is also, I think, a little bit easier, because a lot of the complexity of the final a query is a little bit reduced, because you don't have all those between statements anymore. It's a single date that you're going to use, which is the low DTM of the partition that you're using. And in the end, the other thing that you can do with those dimensions is that you're going to look at the way how those dimensions evolve over time. So you can look at, for example, how your suppliers or how your customers are changing over time, and that might be some other way to look at those things from another analytical perspective. So there's the future of Airflow, which is also very interesting. I'm looking at, for example, now what is being done as quite experimental, except that Airbnb is already doing it, which is where people are looking at YAML files that they're generating, and those YAML files are more like instructions about how to generate certain pieces of your ETL code. So in this case, they're looking at A/B experiments. You'll probably have a team that works with A/B experimental data, and instead of telling them, here, write your own DAG in Python, you would create a framework that, using all the correct ETL principles that you need to apply, you are going to generate those DAGs for them using the input that come in from the YAML files. So this is sort of like a way for other people to make it easier for them to write their own A/B testing experiments, where the complexity of how they're really set up is left with the data engineering team, for example. And that is, I think this is a very interesting thing that is currently happening in the community as well. And the other example that is useful to give is if you think about business analysts, they are usually defining the metrics that you want to have in your analytics pipeline. And when those metrics are being defined, they're going to a data engineering team and say, can you just build this for us? If you have all the correct sources in place, like your fact tables and so on, why shouldn't it be possible for those business people to write those metrics themselves? So you would create another YAML file with metric definitions. You will give it a subject, a particular area. And the nice thing about this approach is that inside the YAML file, you have the definite way that this metric is defined. Because usually what people do is that they document the way what the metric means in another system. And over time, because some of the source code might change or some of the data might change, those assumptions or those documented metrics are no longer valid anymore. So this is a very nice way of doing it. Plus that, using these mechanisms, you can also tie in all of the things that happens at Airflow with other kinds of instrumentation, for example, in data lineage. Talking about data lineage, it is Apache Atlas is experimental at the moment. So there's some people looking into trying to extract some of the metadata out of Airflow, the way how that processes data, and try to push that into Apache Atlas. And what that gives you is a lot more insight about how data that you're producing in an end stage and what the sources are and what kind of stages it goes through, right? So if you're really interested in that, I will really recommend also looking at the blog post from Chris Williams. Chris Williams is one of the designers at Airbnb, and he made this excellent blog post about democratizing data. And inside Airbnb, they have this data portal tool that is not open source, but from the tool you can really see the kind of vision that goes behind it, because what they basically created is a Facebook for data. So it's not just data and the relations with other data, but also data and the relations to other people and how those people relate to other people and then how they relate to data again. So you can see a whole landscape of how data is being used in your organization, and all of that data isn't input manually, but it's extracted from log files and other sources, for example from Tableau and from GitHub and from Hive and all those catalogs. So I think Airflow also starting to get involved in this lineage problems, and Apache Atlas is a very interesting development. So in the end, what you see, especially with the future of Airflow, is that data engineering is typically about us, developing the data pipelines, and that you are, going to put your efforts into place to construct them, to code them. But as a very good challenge is that you can also think about metadata engineering, that instead of creating those pipelines yourself, you're going to think about frameworks, the machinery that creates the pipeline, so that other people can just put them together and work with the data a lot more, so that it will open and scale out more your data capabilities with the organization. So thank you very much for listening.